Quantum computing, blockchain, deep learning, augmented reality. Jargons of modern computer world. Computer has come a long way now. These fancy words scares a lot of newbies in the programming world. I guess काफी programmers को पता होगा how to reverse a double linked list or how to center a div. But one should always know the basics of computer science. Computer science is mostly about problem solving. This is the simplest picture of computer science. You take the input of a problem, then you need a solution that will be an output, and for that output, something interesting must happen in this block. But computer process कैसे करता है? हमें उसमें interest है. Let's see who does this heavy lifting. आप कभी कंप्यूटर का CPU देखोगे, you will find many tiny transistors on it. Transistors are basically switches which can turn on or off. And these switches are called as bit. Computers को कोई एक language समझ नहीं आती. All that it knows is zeros and one. What about the languages that we write the code in? Java, JavaScript, or Python. So these languages are either compiled or interpreted in a machine code that is a pattern of zeros and one, so that computer could understand. By only having patterns of zeros and one, a computer can do so much, like process numbers, send images, edit movies, and other stuff. Let's consider counting. How do you know this is 123? It's obvious that 1 is at 100th place, 2 is at 10th place, and 3 is at unit place. We use something called as a decimal number, 10 being the base, and we increment the power to that base. Summing up the powers after multiplying that with the digits, you get that number. Computer uses binary system. If you want to represent a number, you keep that bit on that position. So if you want to represent 0, 1 or 2, you will represent them as this. You will see that we have used 8 bits here. But why 8 bits? Back in the days, we only had English keyboard for programming. So हमें सिर्फ उतने characters and number represent करने थे जो एक English keyboard में थे. 8 bits provide 256 combinations of zeros and one. Also, in the early days of computer, it had only 8 bits of computational power. So we standardized 8 bit as 1 byte. We also agreed to make a character encoding standard called as ASCII, which has codes to represent text in computer. It also includes characters like capital ABC and small ABCs. But how does a computer understand the difference? हम humans ने decide किया, let's use this number to represent the characters as well. Ask a computer to represent A as 65 and B as 66. अब computer कैसे differentiate करेगा? What is 65 and what is A if both are represented in the same pattern of zeros and one? So in the context of a program that people like you and me write, हम computer को बोलते हैं कि take this pattern and use this to represent according to the program. मुझे 65 को A represent करना है और 33 को exclamation mark. And that's how you see different file formats today, like Excel, JPEG, Docs, and the other one. जैसे अगर मैं Excel use करूँ, then a specific pattern of zeros and one can be represented in a number. If it's a paint application, I may use the same pattern to represent the color red. That's why you can also do math problems with a character in a computer program. Basically, any patterns of zeros and one are interpreted differently in the context of a program. You also see emojis in your mobile or PCs. Again, for a computer, it's only a pattern. We cannot represent in ASCII code but in Unicode. Unicode is another standard which uses many more patterns to represent anything we like. It uses 16 or 32 bit to represent a pattern, like 1F4BB, a Unicode, which is an emoji for a computer. Now let's come to the size comparison of it. The smallest memory in a computer is a bit stored in a single transistor. You put 4 bits together, you get a nibble. Then you put 8 bits together, आपको मिलेगा एक byte. 1024 byte is 1 KB. A SIM card has a memory of 256 KB. 1024 kilobyte is 1 megabyte. A CD can hold 15 to 650 MB of data. Now if you take 1024 megabytes, you get a gigabyte. A DVD can hold 4 to 8 GB of data. Similarly, if you take 1024 gigabyte, then you get 1 terabyte. A hard drive's capacity is around 1 to 3 terabytes nowadays. I'm not a pro in animation, but I hope you get the idea by this chart. But why 1024 and not 1000? Computer like the number 2, so everything is expressed in a power of 2. So 2 to the power 10 is 1024, and that's why it's 1024 bytes.